Okay, if you're watching this screencast, and hopefully you already know what a derivative is, it's an instantaneous rate of change. And we can take the derivative of a function, and then we can take the derivative of the derivative. And that's just called the second derivative. And if the first derivative is dy over dx, and we write that as f prime of x, then the second derivative is d squared y over dx squared, and that's called f double prime of x. You can even have a third derivative, and that would be d cubed y over dx cubed, which is f triple prime of x. And if you have enough degree of your function to begin with, you could even do a fourth derivative, and that would be d4y over dx to the fourth. And after 3 primes, we go ahead and just start using numbers. So that means the fourth derivative of f with respect to x. So let's do a quick example. We're going to find the first and second derivatives of this function. And so f of x is 2x to the fourth minus 3x squared plus 10x. That means that the first derivative is 8x cubed minus 6x plus 10. And the second derivative is the derivative of our derivative. That's going to be 24x squared minus 6. That's all there is to it. And if we wanted to find the third derivative, we could even do that. 48x. Okay, so why would we even worry about higher order derivatives? Well, if the position function of an object is given by function s of t, velocity is the rate of change of position. So v of t is the first derivative of our position function. And acceleration is the rate of change of velocity. So the acceleration is the derivative of velocity, which is the second derivative of our position. So that's really important to remember. Starting with a position function, you take the derivative, you get velocity. Take the second derivative, and you get acceleration. So let's take a look at a problem here. The velocity of an object is this function right here. We're supposed to find the velocity and acceleration when t equals 3. Okay, so v of 3 is 36 minus 3 squared, which is 27, and that's in meters per second. A of 3 is going to be the derivative of v. So v prime of t is a of t, which is negative 2t. So a of 3 is going to be negative 2 times 3, which is negative 6 meters per second squared. So what can be said about the speed of the object when the velocity and acceleration have opposite signs? Well, if the velocity is positive and the acceleration is negative, then that means the object is slowing down. If the velocity were negative and the acceleration were positive, it would still be slowing down. As long as they have opposite signs, it's slowing down. If they have the same sign, it's speeding up.